according to that amount of current passing through your body. If it is 0.01 amperes, just you can feel that shock, right? So isolate the current increases and reaches the maximum amount 0.07 amperes. Just a second. Here 0.07 amperes current is allowed through your body just 1 second through your heart. Automatically, it can kill the person, called as fatal dose, which causes death. Right? Which causes death. So this is we learned in the morning. Then here one more point is there to understand. That is here simply what about the direction of current? Right? So here, while it is passing through any material, it chooses the direction in which path, in which path it has least resistance path, least resistance path. So by the resistance, it can change its direction. Right? So it is not compulsory to maintain always a particular direction. It can change its direction depending on the resistance. So through which part it can offer the lowest resistance, in that path it can pass into the ground through your body. So that is only about electric shock here. It is combined effect of resistance, voltage, and current. Right? So now we are discussing about simply the factors which are affecting the resistance, right? Factors affecting the resistance. So here already we have decided, right, what are simply in a activity 1, right? Activity 1, nylon wire, copper wire we used it, right? Here, nylon wires not conducting the electricity, copper wires are conducting the electricity, right? So then we have decided that material size here, conductors to insulators, right? So based on the availability of free charges, they may act like conductors or maybe the insulators. So here, nature of the material is affecting the resistance, right? So some are having the more resistance, some are having the less resistance, right? So that is what the material substance we use it to prepare that wire, right? So nature of the material. Then we are understanding the physical conditions of the material, like what its length and its cross-sectional area, right? Length, cross-sectional area. Right? Why we are giving importance to this one? Here, what happens if the length increases? Availability of free charges changes. If the cross-sectional area also changes, automatically it can influence the availability of free charges in the conductor. So that's why we are giving importance to the length and the cross-sectional area also. Right? Then here we are also giving importance to the temperature. We are also giving importance to the temperature, right? So these are the factors we are trying to understand in what way they are affecting the resistance, right? Factors influencing the resistance. So that we need to discuss. So here for this, you need to collect a few materials, right? So what they are here, simply to make a circuit, what are the minimum required things? Connecting wires, right? Connecting wires, bulbs or bulb. Simply a bulb is needed to check your circuit whether it is working or not. Then you require switch to on off. Here you need to understand about the resistance increasing with the length, increasing with the cross-sectional area, increasing with the temperature and changing the material. So changing the material, that means you need to collect the different materials which are available in strings, wires. So they are here made up of iron, made up of copper, made up of aluminum. So these are available wires with us. So you need to collect these materials, right? So they are with different thicknesses. They are with different thicknesses, right? Length same and different. So here lengths you need to collect once they are with same length and they are with a different lengths, right? Thickness also same and different, right? So here while you are changing thickness and length, just depend only on one material. No need to change the material nature here, right? So same thickness of wire made up of suppose copper, right? So that you need to collect sample wire. Then changing the length, thickness same, changing the length. If thickness is same, changing the length. If the length is same, changing the thickness. Like this we will maintain. Like that we will maintain here, right? Sound is low. Just a second, I will adjust the settings. Right. So now individually we can verify that. So first you need to make a circuit which will useful for all the activities here. Common circuit, right? So here you are measuring the resistance. You are measuring the resistance. How to measure the resistance? Using multimeter, or you can use ohm meter, right? Suppose if you are using multimeter, just connect the ports, right? Connect the ports end of the wire here. Suppose if it is a wire, one of the port is connected here and the other port will be connected at here. So the ports are connected at the two ends of your conductor. There you can measure the resistance, right? There you can measure the resistance. So here simply I'll make a circuit. First I need to take a battery, right? With the battery I am connecting the electric components. First I need to verify my circuit. So for that I am arranging the switch here, then connecting the bulb here, LED bulb, right? Then verify by switch on, bulb is glowing or not, just you need to check. After this, what to do? Just here you are arranging your materials, right? One after the other. So here first of all you are continue your activity using a bulb here. So here simply I am conducting this activity first using a ordinary bulb. Why I am choosing bulb here instead of LED bulb? Why I am choosing normal bulb, ordinary bulb, right? So here simply while you are glowing the bulb, the temperature of the bulb changes, temperature increases, right? So this is the reason why I am using ordinary bulb instead of LED bulb. LED bulb temperature will remain constant during connected in the circuit, right? So when the current is flowing through ordinary bulb, its temperature changes, right? Its temperature changes. Don't use the LED bulb here, use ordinary bulb, right? So I am using this bulb because of that reason. So before switch on, right? Before connecting your bulb into the circuit, just you need to measure the resistance of the bulb. So how to measure the resistance of the bulb? Use your multimeter, right? That ports are connected to the terminals of the bulb here, right? before connecting that into the circuit. So that multimeter will display something reading, that is the resistance of the bulb before you connect into the circuit, before you connect into the circuit. So here, why you are measuring this resistance before connecting? So here you are measuring the resistance of the filament of the bulb, tungsten filament. So filament of the bulb gives you something a resistance before it connected at a room temperature. At what? Room temperature. Right? The bulb is cooled, no heat, right? Not gets heated. So that reading you need to note down first, right? Then what to do? Just you have to connect as you see in this circuit here, right? So once you connected this bulb into the circuit, what happens? The bulb starts glowing, right? A few minutes later, just you need to check the resistance of the bulb. Already you have one measurement. Okay. So that resistance of the bulb, while it is glowing, you need to verify, right? So every 1 minute later, no problem. For every 1 minute, you need to verify that resistance. So you will measure at least 2-3 measurements, right? So for every 1 minute, you need to verify the resistance of the bulb. Then compare the values. Suppose first value is taken as R, right? Before you connect. After connecting, suppose first minute R1, second minute R2, third minute R3. 3 times I took measurements, right? So now comparing these values with the original resistance of the bulb, right? Before it connected, right? At normal temperature, at room temperature, right? At room temperature, resistance of the bulb is taken as R. After connecting that, the temperature of the bulb continuously increases, right? So at T1 degrees Celsius temperature, at T2 degrees Celsius temperature, and at T3 degrees Celsius temperature. Here it is increasing order, right? Increasing order of the temperature. So once the temperature is set to increase, what happens to the resistance? Is it increasing in the same order, or when it is decreasing with the increase in temperature? That you need to compare first. Observe your readings, right? So here, finally, you are going to make a conclusion is, right? What the conclusion you are making here? The conclusion is simply, if the temperature rises, what happens? Resistance of the material also increases. Temperature rises, the resistance of the material also increases. So here, what you are giving the relation between the temperature and the resistance is simply resistance increases with increase in temperature, right? Resistance increases with increase in temperature. So you are making a relation between the temperature and resistance is directly proportional. How they are related each other? Directly proportional, right? So simply this is your observation from the activity number 2. So for this, what the materials you are collected? Simple electric circuit materials, and along with that you are taking a ordinary bulb and a multimeter, right? So already multimeter explained in the morning class. Just you have a selection knob, right? So one thing maybe I forgot to inform you, that is about overload, right? Overload. So here, if the display always giving you 0 or 1 as its reading in the display, if you are finding the value without any change, 0 or 1, this is called overload, or not in the region you are selected, right? The limit is not enough. So what to do? Just you need to change the value, right? So here look at, if the meter reads always 0 or 1, that multimeter reading, right? So it is not in the limit. So what happened? You are required to change the selection now. Maybe you are lower than that or maybe higher than that. So if it is higher than that, it will give you in decimals, right? So that reading units also it can give you kilo or just milli, micro, like that. Okay, so that ohms will be given in a kilo ohms or micro ohms or mega ohms like this, right? So kilo 10 power 3, micro 10 power minus 6, mega 10 power 6, like this you will get the readings. Okay, so these are, right? So are you clear about activity 2? Just give me your quick reaction. No problem. Right. So this is about activity 2, right? So here, can you guess the reason why the resistance of the bulb increases, right? Why the resistance of the bulb increases with increase in the temperature? Can anybody answer me? If you don't know, just use a quick reaction. No idea? No idea? Okay, I'll give you here, right? So here, you learned about random motion of electrons, right? Random with ordered motion of electrons, right? So here, in the conductor, that electrons are moving random with ordered motion. This you learned, right? So many collisions are there. It is making many collisions with the lattice particles, right? So when the temperature increases, that vibrations made by the lattice particles also increases, right? Vibrations made by lattice particles also increases. So this is the reason to increase in the resistance of the conductor. What is resistance? Resistance is nothing. Simply we define that resistance is obstructing nature. Obstructing nature. What it can obstruct? The motion of the charges. The motion of the charges controlled by the lattice particles due to vibrations or collisions, right? So collisions are made. So number of times it is resisted to move, right? Its motion is controlled. So that's why it is taking long time to reach from one end to the other end. So this nature only make the filament to glow actually. Right? The bulb filament glows due to this reason only, right? So bulb gets heated. The increase in temperature of the filament in the bulb is responsible for increase in the resistance of the bulb. So here the reason behind this increase in resistance due to temperature is simply number of collisions increased due to the vibration of lattice particles, right? The fastness, right? Fastness of the vibration increases, right? So this is the reason for increase in resistance. So one of the affecting factor we decided how it is affecting. We concluded resistance increases with increasing temperature, right? Then now I am understanding to know about the importance of nature. That means copper wire, iron wire, aluminum wire, right? In this, which has resistance more or which has resistance less, or if they are having equal resistance, maybe, I don't know, right? So I need to know about these materials behavior, obstructing behavior, right? So how they are allowing the electrons to pass through them, moving through them, right? So that I'm trying to understand here. So for this, what I'm doing, just I'm making a circuit. I'm making a circuit. Excuse me, just a second. So here I'm making a circuit, right? Here temperature I need to maintain constant. So how can I maintain temperature constant? Just I am following the simple trick to maintain constant temperature, right? I don't want to change the voltage. Voltage remains constant. And the surroundings, weather conditions also I will maintain same, right? So at a particular time, right? So automatically room temperature also changes with sunlight, right? So here the time you need to maintain same, right? Duration. Time means not fixed time, duration. Okay, so these you need to give importance. Okay, here just I am just covering this gap using the different materials. But before just connecting this PQ gap, what I left, different metal rods are connected between these P and Q. But before collecting these different metals, I need to take care about these things. What here? Just I am changing or I am observing the nature of the material. I am observing the nature of the material, right? So to understand about the nature of the material, just I am following this precaution, right? So length fixed for any metal, thickness, cross sectional area, right? Cross sectional area also fixed, temperature fixed, right? So these are you need to follow conditions. Maintain the rest of factors constantly. Just you are changing only nature. So how you change the nature? Nature means the substance, what you are using, nature of the substance, right? So you are taking copper, aluminum, and one more iron. So these are the wires you need to collect. Suppose I am fixing the length 10 centimeters, right? And selecting the gauge of the wire, same, right? Gauge of the wire is same. So suppose if you go and meet electrician, they will explain you about this gauge, the thickness, size of the wire, cross sectional area of the wire. Suppose if you observe that what a wiring in new buildings, they will maintain the different wires to connect one to other, right? So that gauge they are maintaining is 1.5 square, 1 square, 2.5 square, 4 square, like that. So it is about the thickness of the wire, right? Gauge, right? The gauge of the wire, thickness of the wire. So I am maintaining this same, right? Maintaining this same. So it will be purchased from electrical shop only, right? Then collecting each material for 10 centimeters. So copper 10 centimeters length, aluminum 10 centimeters length, iron also 10 centimeter length, having the cross sectional area same, right? So length fixed, area fixed, temperature fixed, and materials are different, copper, aluminum, iron. Then what to do here? Just by connecting it, You need to verify the amount of current passing through them. Sir, actually you are measuring the resistance. Again, you are saying about current. Nothing. So here, I already given you the relation between I and R. I and R. What is I increases with decrease in the resistance. I decreases with increase in the resistance. So here, I is inversely proportional to the resistance. Right? Or I into R equal to constant, I said in the morning class. That constant is what? Potential difference. I into R equal to I. Ohm's law, another form. I is proportional to 1 by R. Or I is inversely proportional to the resistance. In this way also you are able to verify Ohm's law. Right? So that's why. So here I am measuring the current instead of measuring the resistance. Okay, if you want to measure resistance, use your multimeter by selecting the knob. Set your knob to the resistance or set your knob to the current. Anything you can measure. Right? So once put here iron, then take the value of current, something you will get. Don't change the remaining things, just replace the iron wire with the copper wire now. Then again measure the value of current, right? Measure the value of current. Then replace this copper wire by aluminum wire. So once you measure the current by placing the iron string here, iron wire, you measured the current by placing copper wire, you measured the current by placing here aluminum wire. So you got 3 values. Then compare them. Do they stand for the same value? Because I set into this circuit same voltage and I maintain the length is same and I maintain the thickness is same. I maintain the temperature same, right? These are all same, but the nature is different. Material, I use it differently to join this or to fill this gap PQ, right? So here, with that, what I'm going to notice here, they are not giving you equal amount of currents. They are giving you the different values. Why maybe it is? Why maybe it is? Can anybody answer me? Why I am getting the different current values here? What may be the reason? Can you guess the reason here? Anyone? Abhinay, Richaran, Vikrant, Rohit. No one able to answer here. Simple. What happened with the material nature also? Availability of a free electron count changes. Do you agree or not? Do you agree or not? Just use your quick reaction. Do you agree with my statement? What I am saying here? With change in the material, automatically the count of electrons also changes. Do you agree? For example, I'll tell you about the atoms. Aluminum is there, right? Aluminum is there. The next here, copper is there. Count of electron vary from one to the other or not? Aluminum, it is 13, copper 29, right? Then here, the availability of free charges changes. The availability of free charges changes. So due to that reason, here you are measuring the different current values. Measuring the different current values. So that is the reason to observe here importance of a material. So every material we are not using in making of wires. Did you see other than copper, aluminum in making of wires? They are available with copper or aluminum. Why not iron? its resistance is more comparing with the aluminum and the copper, right? So that's why you are not using. Okay, then the most abundant metals are these copper and aluminum, cheap, right? So these are we are using in making of wires. Are you clear about this? Are you clear about this activity 3, how to conduct? If you are checking one of the factor, verifying with your one of the factor, then what to do? Rest of them you are maintaining constant. Keep it in the mind, right? So give me a quick reaction. Did you understood about this activity 3? Is it clear? Give me a quick reaction. Yes. Right. Join immediately. This time completed. I'll start the next session immediately.